rule. And again, because we did the chemical contaminants early rule, you'll see a lot of redundancy in this. So this is module 8. We're going to define what the radionuclides rule is. We'll talk about the regulatory overview. If you haven't seen a pattern now, surely you're seeing it develop. In other words, what's the regulatory overview? What do they say? What are the health effects of this particular contaminants? And then what are the various methods for compliance? All right, radioactive material enters the water in several ways. It's deposited in surface water from the air. We talked about the naturally occurring incidents. So in groundwater, through erosion, seepage, human activities such as mining, farming, stormwater, industrial activities, or the dissolving from your underground mineral deposit as the water kind of washes or flows over them. Water is a universal solvent, so anything that flows over it is going to pick up those impurities there. Nuclide, by definition, is the atomic form of an element characterized by the number of protons and neutrons that are in the nucleus. And of course, you remember the outer shell is the
nuclei.
No, the outer electrons.
Oh, the electrons.
Right, because we got the positive, the neutral, and traction, opposite, electric, negative. Yeah, the electrons on the outer shell. Chemistry 101. So the radionuclide is an unstable form of this particular atom nuclide. There is what we're looking at. And it's going to try to reach stability, therefore giving out radioactive elemental rays there. All right, so regulated radioactive drinking water contaminants. We saw them earlier. We have a combined iridium, which was the 226, 220A. We have the gross alpha emitters. We have the beta particles and photon radioactivities. And remember, uranium was added in 2000 with the revisions there. We have maximum contaminant levels for each of them. And again, the goal was for all radioactive material. What was the goal? 0, super, super, super. The source, as was pointed out earlier, most of the source is from
naturally occurring.
Naturally occurring, absolutely. 80%. 80%. Okay. Some of the health effects, when you look at the health effects in each area, what is, again, similar in all cases, is the increased risk of cancer. When you start looking at uranium, and now we see additional effects with your kidneys there. Okay. So how do they enter the water? Again, naturally occurring trace amounts of blinding radioactive elements are present. And we do have that 20% from your man-made sources. These are areas that manufacture or dispose radioactive substance, as well as the improper disposal practices that may have gone on in the years past, you know, when it was unregulated, and you buried it as far as you could. Now we're taking it out to sea. The requirements of the 2000 radionuclides rules that apply to the community systems. And again, we know what a community system is. And it's a consideration for future proposal for your non-transient, non-community system. Not a requirement, but again, it's just a consideration for future proposal for that group there. So uranium is one of the things that was added in 2000. And we're looking at 30 micrograms per liter. Again, the goal is still 0. And it's to also to ensure that all water entering the distribution system is tested, as well as listing the various treatment options, which we kind of briefly talked about earlier, the ion exchanges, reverse osmosis, filtration in order to remove them. So, treatment options, we have ion exchange, reverse osmosis, lime softening, green sand filtration, coagulation, along with filtration, all possibility for removal of these radionuclides. And that's what this particular chart here is, simply telling you the best available technology to remove the various contaminants. This one is in your book on page 8-8, if you want to refer to it at a later date, because I know you can't read it up here. So, are there any questions, comments, concerns, or issues? I think he's just happy to, hey.
I have a question,
Yes.
I don't know, it's kind of, I have an RV, and like transient, like, when you go to the campgrounds, or RV resorts, they call them now, they all, the majority of them have their own well, and they service their, do they have to abide by the same regulations?
They have to abide by regulations, but they are transient.
Yeah, that's what I was.
Yeah, that's the
So are
difference
they-
there.
They're a little more lax on their,
So a lot of the community, contaminants and things like that, they may not have to abide by because they are transient, but they are still bound by the Safe Drinking Water Act, yes.
yeah, it's just, I always wonder, because I go to the water is, I don't know, I'll ever drink it, just,
Yeah.
you can always, it's always got some sort of odor, or, I mean, you could tell, it's just coming out of the well, right down the street from you, or whatever, you know, there's not much going
Yeah,
into it.
but because they are a public water system, they fall
Yeah.
up under that umbrella.
Okay.
So they have to meet the minimum requirements for a public water systems. And that you can have confidence that they're doing that.
Yeah, hopefully.
Well, ask the doctor.
Some of these, I mean, yeah, it's, they are serving a lot of people, I just didn't know what, you know, what rules apply to that use.
Well, and as to who's doing the sampling,
Yeah,
doing
who's-
their own sampling.
Yeah, which one's?
Yeah, and in some cases, as we said earlier, any laboratory can do the parameters such as for the water quality, pH, conductivity, alkalinity, orthophosphate. You don't have to be certified, but in some cases, especially when you're dealing with the BACTs monthly sampling and so forth like that, you have to be certified not only to run those analyses, you have to be certified to collect those samples. So there are, you have to go back and, you know, see what the requirements are and what's necessary in order to achieve it. But if it's a BACT sample, certification is required.
In Delaware, the Office of Drinking Water does most of the sampling for those smaller,
Right.
smaller systems.
They don't, do they have to do a CCR? I don't think, they're not.
Not transient.
Yeah, okay.
Because there are people out there all the time.
Right.
That's because people are, even though there's serving a lot of people, we're in and out, so I didn't know if that changed the regulations or.
Because
Yeah,
there
it's,
are-
there are, again, the rules and regs are not as strict, but they have to meet the minimum of the public water system, which all public water systems, a minimum of 60 days.
Yeah.
So whatever falls up under that, you have to meet those rules and regs. All the VOCs, IOCs, SOCs, community systems typically, or your non-transient, non-community systems. Okay, any other questions, comments, concerns, or issues? None? We're going to continue on into the next module. And next, we're dealing with the filter backwash recycle rule. And that is module 9. What is backwash?
What is it?
Mm-hmm. Can you explain to me what it is? Why we need a rule to regulate backwash?
It's all the waste that you remove from the water, or accumulated. I'm not sure I understand the question.
What is backwash?
What is backwash?
What is it to actually do it? I mean, to watch the filters.
Cleanse off the filters, right?
Also, in other words, what you're telling me is that water is sent through filters, gallons after gallons after gallons.
Or you reverse it, yeah. You reverse whatever the filter flow is. to
So
flow out
I'm
the
reversing the
contaminants.
flow with backwash Why?
To get rid of the contaminants that you remove.
Okay, because over time, there's a possibility of clogging of the filter and
Well,
other
that's
issues
one
that
possibility.
yeah,
It's gonna happen.
more than likely it's
Yeah.
gonna happen. To ensure the continual filtration process is effective, from time to time, you have to backwash, right? Okay. when
Cleaning
we-
the filters.
Okay, and when we do this process, what are some of the issues that we may encounter?
You have very concentrated levels of
Whatever
you're
has
removing.
been filtered out, yeah. So do you see the need for a rule concerning backwash? Because of, again, if this gets back into your treated water, anything like that, can be major problems, right? And to get rid of the waste, another issue there. So there's a filter backwash recycling rule. We're going to look at the various methods for filter backwash, recycling compliance. The purpose of this particular rule, as the purpose of any particular rule, is protection of the environment, protection of human health, being the most vital component here, by minimizing the risks associated with cryptosporidium in the recycle flow. What is cryptosporidium?
Intestinal parasite.
Yeah. Good thing, bad thing. Yeah, it could be very, very bad. Any of you all recall what happened in Milwaukee in 1993? Oh, come on now. Yeah. All right, Milwaukee, 1993. Over a span of 2 weeks, something came through that plant. Now, they realized that their filters may have been compromised at the time, but it passed through within a 2-week span. Initially, what they saw were there were people coming forth that had a compromised immune system that were affected, and at first they didn't think, oh, it may be the water source, because these are people that already have issues. Or 100 deaths.
They were hoping.
Yeah, and then when the average Joe Blow, Sally Sue, oh, got a tummy ache, diarrhea or something, and it was like, oh, there's a little more to this than recently thought. So over 400,000 people were infected or affected by this. Again, malfunctioning of the treatment plant, they became ill with stomach cramps, fever, diarrhea, dehydration, and it was caused by that pathogen cryptosporidium.
104 people died?
104 people.
Wow. Now, who got blamed
That's
for
a
that?
document deal there.
What's that?
Well, we don't play the blame game. We try to find the source of the problem to prevent it from happening again.
Yeah.
We want to make sure
You
again.
got operators who has a job? Whether you get it or not. Unless
Yeah.
somebody had to, you know. But, you
There
know,
were
it's-
investigations after
It was
investigations.
a filter issue, I
Yeah, it
believe.
was a filter issue.
Yeah.
One in which they knew about.
Oh, okay.
Yeah, it was compromised, you know, before it happened. And what's unique about cryptosporidium, we disinfect the water, and usually with disinfection, we think that takes care of all organic material. Chlorine does nothing to cryptosporidium in Germany. Okay. It forms an oocyst which protects it from chlorine, so they are chlorine resistant. Okay.
So
So
what
that's,
is it
that's the
that-
reason there is a problem. It's highly resistant to chlorine.
So they're filtered out.
Huh? They have to be filtered out. They,
Huh.
excellent. They have to be filtered out.
Wow. So we could have filters full of that.
And you're testing, because if you are a water source, it's been mandatory. So you know if you have these, because you got to test one, you have to
Yeah.
make sure that they're filtered out.
Well, we're a small utility, but we were required, under one of the, I can't remember which one, yeah. We
Yeah,
did it
surface
years
water
ago.
treatment rule.
Yeah, that's right, and we had to do it for 2 years, I think.
And you're probably on reduced because it's a continuous thing.
Yes, I believe so, yes, and we didn't, our numbers were very low.
Okay,
Fortunately.
excellent. And which means being very low, you fell into bin 1, 2, 3, 4.
Right.
Yeah.
That's right, yeah.
Mhm.
I think we were, yeah, bin one.
Bin 1 is the lowest,
Yeah.
yeah. So,
But
this
yeah, I
is
remember
not
I had to
best
take
for fun.
samples, and I don't know if you remember that. It was quite an involved process.
Yes, it is. So, the way to reduce these, filtration, okay? So primary objective of your filter backwash, recycle rule there is to ensure adequate level of public health protection by minimizing the risk associated with your cryptosporidium and your recycle flows. Under the interim enhanced surface water treatment rule and long-term one enhanced surface water treatment rule, you have to be able to demonstrate at least a 2-log removal of cryptosporidium for your surface water and your groundwaters under the influence of surface water. There are a lot of streams, recycled streams that are out there. There are 3 that are regulated. There are 3 regulated recycled streams. We have the spent filtered backwash water, the thickener, supernatant, or liquids from the dewatering process. These are the ones that are regulated, but there are a lot of others that we'll look at that are not regulated at this point. Recycled streams may affect the treatment processes due to hydraulic surges or high concentration of contaminants in the recycled stream. That's why we're looking at these 3. Other unregulated streams that we may encounter would be filtered waste or membrane concentrate, ion exchange regenerant sludge, as well as your diatomaceous earth slurry. Criteria of the FBBR, your systems are classified as a subpart H system by EPA. They need to make sure that they are adhering to this filter backwash recycle rule. And so what are the subpart H? We're talking surface water and groundwater under the influence of surface water. They are subjected to this rule. Or you may have a system that treats water by conventional filtration or direct filtration. They are too also subjected to this particular rule. What we mean by conventional filtration is that you have your coagulation and mixing, and then you have a sedimentation basin in conjunction with that, and from the sedimentation basin, you have the filtration occurring. So that will be your conventional flow. For non-conventional filtration or direct filtration, we're going straightly from addition of coagulant, rapid mix to filter. There is no intermediate step of the sedimentation or the clarifier basin. So that would be direct filtration as opposed to the conventional one. So there are 3 components of this rule. We have reporting, we have recycle return location, and of course record keeping. With the reporting portion of it, you want to make sure you provide the state with the schematic of your plant, showing the origin of all flows that are recycled, the recycle flows from the previous years, and you want to make sure you provide them with the highest that is observed during that time, as well as the design flow from the treatment plant. Another part of the reporting is the state-approved operating capacity for the plant must be a part of this report. And one of the things you don't have to be concerned with giving to the state is, or EPA, is the chemical dosing information. Of course, you will be keeping that because that's a part of your daily operation if you're using any kind of chemicals. Recycle return location. The recycle stream should be returned from all the processes of the system, existing filtration, introduced at a point that incorporates all treatment process, or you want to begin necessary capital improvement to move the recycle location or request approval for an alternative location there. As far as record keeping, we're going to list the recycled streams and frequency of return, the average max maximum backwash rates, processing minutes, not based on how long the operator wants to, but what was the actual time, what was the recommendation? Is there any telltale sign when I need to backwash?
Finish work, then it starts rising,
Okay.
maybe
Oh,
your
the
contaminant
person said
levels.
finished work.
Yeah, finish work. Contaminant levels start maybe going a little higher than they normally are.
Okay.
In your
so
finished water
turbidity.
samples.
Mhm.
Head loss, like those.
Head
stuff.
loss.
Yeah,
And so what are we looking at for head loss? Whenever it's, is there a range?
I'm just trying to think, 67, I think.
Yeah, okay, 67, 68, 6 to 10
Yeah.
feet.
I'm sorry,
When there's a head loss between 6 to 10
6 to
feet,
10 feet.
that's when you start looking at it. Of course, you mentioned turbidity. And again, just based on, what does the manufacturer say that those filters can handle? Have you ever picked up your book and actually looked at what?
that's what we run ours off, they all run on timers more than anything.
Okay.
Unless we see some signs, of the other
That
things
you have to do
happening,
differently.
then we'll manually override it and
Yeah.
backwash or flush the clarifier, whatever's necessary, but for the most part, everything runs smooth, it goes off timer.
Okay, excellent, excellent. All right, record keeping, the time of treatment provided for the recycled streams before it re-enters the conventional or direct filtration process must be recorded, as well as the physical dimension of the utilization or treatment units, your hydraulic loading rates. Do you know that? Your hydraulic loading rates? What's the system designed for? Yeah, because you know, again, the dimensions of your base. In other words, again, it goes back to the recommendation. If I'm putting one through that filter, then what they recommend, what does that do with efficiency?
Typically, yeah.
Yeah, so you gotta be aware
Yeah,
of that.
They say our filters can do more than we,
Sure.
the manufacturers say that they should be able to run a lot more than we actually do.
But it doesn't.
In reality, it doesn't, we start having all kinds of problems with turbidity issues and.
So you know what you need to go back to do? Looking at the quality of your raw water.
Well, it's a
That
surface
little
water.
thing.
Well, you got a roller plant. Yeah, both of them, it just seems like they never live up to what they were
What
sold
the-
as, you know,
yeah,
it's,
yeah.
they work great and everything, just slightly reduced capacity than they were sold, you know.
So look at again, the source of the
That's-
water.
Yeah, and there's so many
Yeah, because if the
variables.
quality changes,
Yeah.
you're not gonna get the output.
There's-
And of course, they're giving you the best case scenario when they're trying to sell you the.
That's, I mean, there's so many variables in the industry, like, for them to say, yeah, this filler will do this much, and that, it's like,
Right.
there's so many different variables. How could
Humidity,
we
it's
say
like,
that?
yeah, temperature, what.
It's, but, yeah, that's. yeah.
Part of the game, huh?
Yeah, exactly.
All right, we have a checklist on, I think that's page 9-8, which incorporates a lot of the stuff that we just said, as far as the record keeping and all of that. And that's a good checklist to go by to make sure that you are adhering to everything, the plans can actually have it or origin of recycled streams, typical hydraulic loading rates, maximum, all of that right there. It's just a good checklist to keep handy and make sure you have all that information. All right, your 3 regulated streams, your spent filter backwash, it is concentrated with microbial particles, such as Giardia and Cryptosporidium, which poses the problem when you have huge amount of this. Your thickener supernatant, your thickener is a system in which there is a separation of your liquid and solids by gravity. So your slurries and things like that, clarifiers, sedimentation bays, and backwash and holding tanks, lagoons, you could have, again, elevated microbial contaminants in that sludge component because they've all settled down for the most part if they were not colloidal. Liquids from the dewatering process, which was the third recycled stream that was regulated. So we have dewatering processes such as your belt press, centrifuge, drying bed. Of course, in the part that has been concentrated where the water has been removed, you may have again concentrated amounts of cryptosporidium, aluminum, if your plant is using alum for coagulation, as well as some other things that may be present of concern. Unregulated streams, if we have a filter to waste, this is the wastewater and filters being prepared to return to service. It is the second largest amount of waste stream generated by the plant. This water can be recycled or it can be disposed of. We have membrane concentrate reject. Remember, this was the 20 to 40%. If you're looking at an RO system there, it can either be returned through the membrane for treatment or disposed of through land application, sanitary sewer, or surface water. Again, any of this right here, you gotta make sure you have the right permit. If you take this option, I can't just go out there and put it on the land. I gotta have a permit for it. I have to do the testing for it. And it has to be, again, within the right levels to land apply it. If not, it has to go to a land field. So it has to meet the right parameter for that. Surface water, again, anything you put in the surface water, you must have a permit in place for that. For ion exchange, residual streams generated when the resins are regenerated can be rinsed or backwashed. Sludge from your softening plants or contact clarifiers, the solids are usually recycled. In other words, it's a part of the treatment process. So you have that continual recycling that goes on. Slow sand filter to waste generated over 1 to 2 days of slow sand lightening process. And then we have the diatomaceous earth slurry generated when the filter is clean. The volume may be concerned if you're going to recycle it because of the concentrated items that may be here. And then minor streams, we have waste from spills, laboratory analysis, wash down of the plant facility leaks. Again, most of this, for the most part, is a very small amount of concentration of volume, so they're usually just recycled. Some consideration and modification, you want to take into consideration and try to minimize the impact of recycling and backwashing practices that you are dealing with. Look for ways to optimize the process. That's not a requirement, but again, anytime that you can optimize what you're doing, it enhances your efficiency. It prolongs your equipment also. You can implement things with or without equalization basins or treatment of the streams. So again, just explore all opportunities there. And it may or may not require capital improvement. Not everything has to be an act of Congress. You can think of little small things for improvement to improve the process and get a better quality. Make sure whatever you're looking at as far as modification, you're testing prior to implementing this. And consult the state agency. Remember, any modification needs their stamp of approval. Treatment options for your recycled streams could be just simple as sedimentation. In other words, you have a lagoon, you have land space, possibilities, and everything there. Now, what do you think you need to do from time to time if you have a lagoon system?
Dredge it.
Absolutely.
That's what we're
You
gonna
can't
do.
can't just sit there. There are rules and regulation. Every so many years, gotta clean it out.
Ours is about 2 inches deep at this point. Like,
Only 2 inches and you're getting ready to do it?
we filled it up.
Yeah.
So you're talking about you have 2 inches of supernatant on top.
Oh, we have, well, it's about.
Only 2 inches left, right?
Yeah, we have about 2 inches of water.
I thought you were talking about 2 inches of
Room.
sludge, and I'm like,
No,
oh,
room.
room.
It's our 6
How
foot
many years
deep lagoon.
has it been?
Oh, it's 15, 18 years.
Oh,
It's
25?
20 years?
20 years.
20.
Okay.
Yeah, the plant's been there 20 years, so since.
Yeah.
Yeah, it's about time.
It is, that's,
It's
well, we
about
have 2
time.
of them, so we just, we shut in the other one now, that we got one full, so
Yeah.
while we're working on this one, we'll shut in the other one.
All right, so it should be designed for what? For what? For what?
For every so often, slightly.
Not every 20 years.
Every
what does
20
that
years.
say?
Well, it was pretty
Yeah.
neat to begin with,
And
there's a lot of room there.
Is it on your treatment site?
Yes.
Go back and review what the rules and regs are for Delaware. I know in Texas, we have a 5-year.
Oh, I don't believe there is any,
There's
requirement
none
down
here?
there, no,
Okay.
that, I mean,
Yeah.
we'll probably get around to a little more frequently. There were some modifications made so we could, utilize the other pond easier, and, it was a leftover from an older.
Yeah, the ponds, it was a paper mill before we got it.
Mhm.
And they had the 4 ponds out there for, apparently I heard when we first acquired the property, the ponds, like one was purple and one was pink.
Dye.
They had like the dye from all the paper pulp and all the extra stuff. They used to blow that into these ponds. So they must have been done then, when we got it, and then, yeah, I don't know, but
The other thing you want to make sure is that, and again, you need to make sure it's lined with an impervious layer to prevent groundwater contamination. Over time, even these layers that, they say are the best of the best will degrade, so keep that in mind too. We have chemical additions. These are sedimentation enhanced by the addition of chemicals. In order to determine what's the right amount of chemicals, jar test helps to tell us what to dose in order for us to have better block formation for sedimentation to occur. Tube and plate settlers. Some people believe these are a lot better than your traditional sedimentation because, again, you don't have to have that surface bottom. You have all these tubes where you have a much wider surface area here. So it allows for greater loading rates. One of the disadvantages, your tubes and plates can easily clog, or uneven flows can create inefficiencies there. The type of chemical mixing used depends on the plant layout, your hydraulic grade line, and design flow rate. So you probably need a little more experience in order to operate these than others. Advantages and disadvantages, if they're properly designed and operated, of course, any of your sedimentation methods will remove significant amounts of turbidity as well as other particles. If it's improperly designed, it's going to lead to poor solids removal. You may need maybe an extra basin, equalization basin, or capacity, or storage. You want to make sure you're removing sludge frequently to avoid compromising the active storage and treatment capability.
frequently.
Huh?
Frequently.
Frequently, you got that, huh?
Yes,
That's EPA.
that's them.
Yeah,
That's the ones.
okay. Treatment options for recycled streams. Micro sand assisted filter sedimentation has been around since the 70s. Again, this relies on improved sealing through the addition of coagulant, flocculation, as well as clarification. Your micro sand is separated and recycled through the system numerous times. One of the advantage, quick process startup. However, disadvantage, short processing time. Also requires a small footprint. And then we have the dissolved air flotation. You see this quite a lot with your water treatment, wastewater treatment areas. Side stream is saturated with air, high pressure, injected in the flotation tank, mixed with the incoming recycled streams, and your air bubbles with the solids attached, kind of move up. Remove by a sprinkler or a flooding over the tank over a wheel. Can be very effective in removing those low density particles because the buoyancy of the air helps to bring those up. We also have granular bed options, filtration. Here again, pretreatment by chemical addition with or without flocculation prior to the filter. It's usually practiced with beds. Expected advantage is higher rate of particle removal, but it's gonna cost you a little more. The complex or the process can be complex, and you create a greater volume of waste. Now you have to figure out what you're going to do with that additional waste. And then membrane filtration is another option for the recycled streams. We're talking the microfiltration, ultrafiltration, as well as particle removal. It's going to remove very, 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 very high levels of the smallest of particles. It's used to treat variation in inflow water quality with little or no adjustment to the process. Again, complex equipment is employed with the membrane filtration, and they are subject to fouling over time. You're going to get some accumulation. Okay, and again, depending on which one you use, you can see the different sizes down to reverse osmosis, which that's taking it a little far with your recycled streams. You're not trying to create the pure water. And then disinfection. Disinfection or chlorination is recommended for your recycled streams because there will be some biofilm that gets through there. You're going to take into consideration the level of inactivation of microorganisms that you're working with. And ask yourself, should it be used alone or with solid removal? And you want to make sure you're looking at the potential impact of your finished water quality, especially. I have free chlorine, I have these naturally organic material present, free chlorine, NOMs. Now I have the formation of, yes, those trihalomethane, acetic acids. What impact is that going to have? And you want to look at the pathogens of concern in the recycling streams. Is it just Giardia criclosporina, or are we looking for other things such as E. coli? So possibility. So lots of things to think about when you're looking at the treatment options for the recycled streams. Are there any questions, comments, concerns, or issues?
And again, this rule applies to surface water or groundwater under the
There you go.
Okay.
Because typically, they're the ones that will employ the filters. You know, the ones that are required to have some type of filtration, even if it's just a rapid sand filter. Groundwater systems, not a requirement. What's the only required treatment for groundwater? Disinfection.
You were pausing, I was making me, I was getting ready to say disinfection, I thought if he says it's being way wrong.
All right, are there any questions, comments, concerns, or issues? All right, looks like it's time for a break.